Hey there everyone, this is Dan from the Strength Coach Tutor. Hope you guys are all doing well. Thanks for checking out today's video. We are going to discuss sliding filament theory today, all right guys? So there's a lot of confusion between what happens with the A band, the H zone, the I bands, and the Z lines during a concentric and eccentric muscle contraction. So we're going to go through all of those and get a good understanding of what's happening with each of those during a muscle contraction, all right? So before we start drawing things and going into all that, let's first actually identify and define what each of these different components mean or represent. So let's first start with the A band, okay? So when we talk about sliding filament theory, right, it's when actin and myosin are sliding over one another, all right? So what the A band is going to represent is the length of the myosin filament, okay? The A band is going to represent the length of the myosin filament. Whereas what sounds similar, but it's not the same, so pay attention here. It's there's some key details. The H zone is going to be the area where there's only myosin, right? The A band is the length of the myosin filament. The H zone is the area where there's only myosin, right? Because with sliding filament theory, right, as we get more and more overlap, theoretically, then there's going to be less space where there's only one of those filaments occupying that space. So in this example, right, as we have more and more sliding over those two filaments over one another, there's going to be, the H zone is going to decrease, okay? So moving on to the I band is going to represent the area where there's only actin, all right? So you can think of the I band, the opposite as the H zone, right? The H zone is going to represent the area where there's only myosin. The I band is going to represent the area where there's only actin, all right? The Z lines, you can think of these components where it's, creating a segment of that actin filament, but during a concentric muscle contraction, those Z lines are going to get closer together, okay? So let's actually discuss this here, right? So remember, sliding filament theory, we have actin and myosin sliding over one another, right? So as there becomes more sliding or more overlap between these two filaments, there's going to be less space for one of those filaments to only be occupying that said space that it's referring to. So, right, if I'm going through a concentric muscle contraction where there's going to end up being more and more overlap, my H zone and my I bands are going to decrease. My Z lines are going to get closer together, right? Because there's going to be less and less space where there's only actin or there's only myosin occupying those areas, all right? So remember this is a point to write down. During a concentric muscle contraction, the H zone and the I bands are going to decrease and the Z lines will get closer together, or the distance between the Z lines will get closer together, or will decrease. That distance will decrease. What happens with the A band, right? Now the A band again is representing the length of that myosin filament. The lengths of these filaments don't change during a muscle contraction, whether it's concentric or eccentric. The length of these filaments don't change. It's how much overlap there is between the two. So during a concentric muscle contraction, that A band is going to remain the same. All right, the A band is going to remain the same. All right, and again, everything that I just said there is in the context of a concentric muscle contraction. Now, if we were to look at this in the context of an eccentric muscle contraction, everything's going to be the opposite now, right? So during an eccentric muscle contraction where there's going to be less and less overlap between actin and myosin, my H zone is going to increase, right? Because then there's going to be more space where there's only myosin occupying that space. Same idea with the I band and actin, right? I band is also going to increase. The Z lines are going to get farther apart, or that distance between them is going to increase, okay? So during an eccentric muscle contraction, the H zone and the I band are both going to increase, and the distance between those Z lines is also going to increase. But we have one more, right? The A band. Remember the A band, it's looking at the length of that myosin filament. Lengths of these filaments are not changing. So therefore, just as we said in the concentric, during an eccentric muscle contraction, the length of the A band does not change. The A band does not change whether it's concentric or eccentric. All right, guys? So in short, or in theory, right, during concentric, everything is going to decrease, right? Everything's going to decrease or get closer together, if you will, for the Z lines. during a concentric muscle contraction, except for the A band, right? Because the A band is going to remain the same. But then during an eccentric muscle contraction, everything's going to increase, all right? And then again, the A band will still remain the same. Guys, I hope you found this video useful on sliding filament theory and trying to get a better understanding of what's happening with the A band, the H zone, the I bands, and the Z lines. All right, guys, I hope I made that as simple as I can for you. I hope you were able to take away some of those key points that I was talking about. But again, next time, please go ahead, like, subscribe, and comment to this video. And if you guys need more exam prep resources, go ahead and go to thestrengthcoachtutor.com to get all the NSCA CSCS exam resources that you need. All right, guys, looking forward to hearing from you, and I'm here to help you pass that exam. See you soon.